have to let it all go, Neo. Fear, doubt, and disbelief. Free your mind.
Have you ever wanted to be able to jump 20 feet into the air, make your skin impervious to fire, or wanted to be strong enough to rip open a metal door? Well, just stop by your local Ripperdoc in Night City, and you can obtain many body modifications that not only extend your human capabilities, but also provide you with novel abilities. In this video, we will focus on the science behind Ripperdocs and cybernetic implants, or cyberware, in the game Cyberpunk 2077. If you are interested in how current scientific advancements could lead to a world of cybernetic modifications, then stay tuned as we explore the types of modifications available to Night City residents and the current science that could lead towards this futuristic world of cybernetic implantation. In this video, we will cover the cyberware modifications that are available to Night City residents, the biology of the different body systems that you can modify, as well as current science that includes robotics, stem cells, and artificial intelligence. First, what are Ripper Doctors and cyberware? Well, Ripper Doctors, or Ripperdocs for short, are medical practitioners that are responsible for the implantation of cyberware. They can be found across Night City and throughout the globe as humans in this universe have made body modification with cyberware common practice. A simplistic definition of cyberware is technology that is implanted into the human body that enhances its capability, interfacing with muscular, nervous, and other internal organ systems. Early in the history of the cyberpunk universe, this technology was solely used for replacing body parts that were damaged. This is very similar to our current practices that utilize static, mechanical, and sometimes even robotic implantation to help individuals without limbs or other maladies. By the 2010s, this technology advanced into its current state of enhancement with a goal of achieving increased human performance. These goals were fueled by war. Early modifications which supplemented human body parts were then later replaced with ones that could actually enhance the body's function, making you physically stronger and resistant to many insults. Throughout the Second and Third Corporate Wars, the megacorporation Militech further pushed the limits into human modification, enhancing the soldiers. This led to an arms race between Militech and many other corporations such as Arasaka. After the wars, the cybermedical market boomed into the public, where corporations saw more benefit in the means of profit selling these modifications to ordinary citizens, advertising perfection in the form of cyberware enhancements. But could we, and how would we get to this point before we explore the current science that allows for human body and machine or computer integration? We will further dive into a higher level overview of the different types of modifications available in Night City. In order to limit the length of this video, I will only provide a granular look into each modification type. If you'd like for me to do an in-depth analysis on each modification type and the science and technology that can make these modifications possible, as well as whether I believe the enhancements are a good representation of that body system, then please like, comment, and subscribe to the channel and let me know which modification type you would like me to cover. The first area of modification we will cover in this video is the frontal cortex, which biologically functions to control skeletal movement, speech control, and the expression of emotions, and also contains the prefrontal cortex, which has been shown to function in controlling executive functions, or higher level cognitive skills that help regulate behavior, speech, and aspects of memory such as short-term or working memory. In Cyberpunk, the cyberware in this area can mainly enhance intelligence and reflexes by increasing RAM, critical strike chance and damage, and allowing for health regeneration. The frontal cortex is a large portion of the brain, which is a subset of the nervous system, mainly the central nervous system, another bodily system which can be modified in Cyberpunk. Our nervous system functions as a complex network of neurons and other cell types that communicates both voluntary and involuntary signals throughout the body, coordinating function of other bodily systems and transmitting signals to control bodily functions. This is possible through the electrical and biochemical signaling between neurons. It acts as both a sensory system and motor system to sense and control the autonomic and somatic parts of the nervous system. Communication is regulated through the interactions between the central nervous system composed of your brain and spinal cord and the peripheral nervous system that represents the nerve fibers throughout the rest of the body. Cyberware for the nervous systems mainly controls time dilation and evasion, allowing one to react faster when in combat. It would have been appropriate if the game designers included additional sensory related cyberware that might detect other harmful substances in the environment, possibly even detection of different biochemical compounds produced by humans when under stress as a method of predicting when an individual is going to attack you or maybe is lying to you. Another piece of cyberware that represents more of an additional modification to this nervous system instead of an actual replacement of a body part are cyberdecks. Cyberdecks are chips that can be added to the brain and enhances abilities to interface with technology, such as hacking abilities in the game Cyberpunk. This modification allows individuals in Cyberpunk to interface with technology, pushing human function to a new capability that even allows you to scan other individuals and instantly obtain information and statistics on that person. Interestingly, with the current use of convolutional neural networks, classifying and instantaneously obtaining information about an individual's identity, associations, and even physical and genetic attributes is possible today. The ocular scanners in Cyberpunk is just a form of this image analysis software implemented for personal use, but requires modification of an individual's eyes, which brings us to our next modification system, the ocular system. This cyberware is pretty self-explanatory. Modifications are made to the eyes and our visual system. In the game, this is mainly used to enhance vision by providing additional information on your surrounding environment through the use of augmented reality, allowing you to see past the UV light spectrum, scan surrounding individuals for information, and even overlay informational masks on objects to gain more insight into your environment. Scanning someone or something that could be dangerous to you might increase your adrenaline and make your heart beat faster, which affects our next cyberware system that we will discuss, the circulatory system. The circulatory system biologically represents our cardiovascular system that mainly includes the heart and lungs and vascular system, providing all other body parts with oxygen, micro and macronutrients, and allows for communication throughout the body. To no surprise, in Cyberpunk, this system can be used to enhance stamina, health, and overall cyberware usage. It is also in the circulatory system where we find the most well-known aspects of the immune system, including our white blood cells and antibodies. This brings us to our next body system for cyberware modification, the immune and integumentary systems. Our immune system is actually composed of two subsystems called the innate and adaptive immune systems, which detect and respond to foreign invaders. Things like bacteria, viruses, and allergens are all foreign invaders. And overall, our immune system provides us with defense functions against these germs and other harmful intruders. In the world of cyberpunk, modifications to these systems provide additional resistance to poisons and toxins, but interestingly, also provides resistance to other environmental insults such as fire and electrocution. Although not classically thought of as part of the immune system, one could argue that defenses which protect the body from harm could be broadly classified under this category. It is possible that sensors integrated into the body could sense the harm and release chemicals, electroshock, or even nanobots that could cure infection, defibrillate the heart, or provide antitoxin or antivenin in response to incoming assaults. I have included the integumentary system in this section, which represents enhancements to your skin, since the skin is considered one of your first lines of defense and is integral to the immune system's ability to fend off foreign invaders. Similar to the immune system in Cyberpunk, cyberware for this system grants immunity to burns, shock, provides armor, and reduced bleed effects. These are all normal functions of your skin, well, besides preventing shock, but other than that, these make a lot of sense in the world of cyberware modification. In addition to the enhancements on the immune system and integumentary system, cyberware can also be used defensively to upgrade the skeletal system and offensively to modify the hands, arms, and legs. Cyberware modifications to these body parts are all pretty straightforward, providing you with structural stability and allowing increased mobility and physical strength. As such, I've grouped these together. These modifications provide you with increased health, carrying capacity, melee damage, data on weapons you are holding, and additional modifications that allow you to jump higher, have stronger arms, and shoot projectiles from your arms, overall increasing all of your physical attributes. It is on these body parts actually where current scientific advancement has made the most progress. Similar to the worlds of Cyberpunk, our overarching goals have been to replace limbs for individuals that have lost them, and also similar to Cyberpunk, we have created prosthetics that can not only replace but enhance one's abilities. At this point in the video, we will explore the science and technology that is currently being researched and could one day lead to a world of cyberware modification and transhumanism. Similar to the game and the early history of cyberware, our current focus in bioengineering efforts that try to interface human systems with computers and robotics are focused on creating implants that can help the disabled or diseased. Early attempts at such efforts provided us with things such as crutches, prosthetic limbs in the form of peg legs, which were crude devices that had no mechanical or electronic components and merely acted as a physical replacement of missing structural systems. Similar to just growing new bone without any muscle, vasculature, innervation, or skin. Even these simple prosthetics have become advanced to the point where people question their use in competitive sports. Our most advanced technology now allows for the control of these body parts through mechanical and electronic interface, and these can even be controlled by recorded brainwave signals. Myoelectric prosthetics have generated control of these prosthetics using electrical signals from muscle contractions. Ultimately, our goal is to be able to control implanted electronic and mechanical devices with 100% accuracy, whether from brainwave input or some other input source. In this video, we see researchers at the Johns Hopkins University Applied Physics Laboratory helping a patient control his modular prosthetic arm. Using a surgical technique called sensory reinnervation, nerves are relocated in the arm and used to send signals to sensors that can then control the prosthetic, and even send signals back to the user to mimic the sense of touch. Furthermore, this patient underwent osseointegration, another surgical procedure that implanted a custom titanium implant directly into the marrow space of the bone. This implant can directly attach to the prosthetic arm and allows for better integration and more comfort when using the prosthesis. These are huge advancements in the endeavor to control implanted devices, but there's still a long way to go between here and what can be done in Cyberpunk 2077. Interestingly, our use of electronic stimulation to control biology is even more advanced than our ability to control robotic or electronic devices using biological signals. In this video, researchers have attached a device that can electronically stimulate a roach's antenna to control its movement and direction through a smartphone. The wirelessly controlled device sends signals to the roach's nerve bundle, which stimulates the roach to move in a specific direction. This is one example of researchers using technology to control an entire organism, but actually, more recent work has led to our ability to even control individual cells that are within a living organism. Here, we see a rat with a device implanted into its brain that sends out very specific wavelengths of light. This can activate individual neurons in the brain that have been genetically engineered to express a light-sensitive ion channel called rhodopsin on their cell surface. This technique is called optogenetics. Light stimulation of those ion channels on genetically modified neurons can activate or inhibit neuronal function. Nagel et al. In 2003 developed the first optogenetic tool by modifying the channel rhodopsin 2 gene isolated from the algae Chlamydomonas and attaching a yellow fluorescent protein to this gene, which itself was isolated from fluorescent jellyfish. Different light-sensitive proteins or opsins can be used in conjunction to complete different tasks in these cells. These are genetically engineered into the cells using a viral transduction method, and the light can be delivered into a living organism to activate the opsins and produce the desired function. As one can see, there are many methods that scientists have developed to interface electronics with biology. A first step into creating cyberware which can be implanted and controlled in humans. To highlight one last advancement, we have also developed a technique called deep brain stimulation, where a neural stimulator is implanted deep into a person's brain to send electrical impulses and help alleviate movement disorders, such as Parkinson's disease and other diseases that cause dystonia. This technique was approved by the FDA in 1997 and has also been approved to help other conditions such as epilepsy and OCD. From this method, we can see that we've already developed techniques to actually implant electronical devices into human brains. With more advanced research, we will eventually be able to accurately control biological systems and electronic or robotic implants with just a thought. Imagine being able to regulate your own heart rate and focus with just one thought by controlling a device that can release chemicals like adrenaline or caffeine directly into your bloodstream at will. You might be wondering how these tasks could even be possible. How could one control electronic or mechanical devices with just a thought? There are two possibilities of how this can be implemented. First, similar to the previous video, one could use brain waves that are read by a chip, either worn or implanted within the body, most likely near the brain. Second, one could have direct brain to sensor connections through the use of specialized neurons. For the latter to even be possible, we would need a large source of neurons that would need to be autologous or compatible with our patient or consumer so as to not get rejected, and a way to manipulate these neurons to connect with electronic devices. To achieve this goal, scientists could actually use stem cells. Stem cells are specialized cells that have two main properties. One, the ability to self-renew or make copies of oneself, or two, they can turn into any other cell type in the body, such as heart, skin, muscle, or brain cells like neurons. These cells can also be generated directly from patients or consumers, in the case of Night City, directly from adult tissues such as blood or skin cells. This method of reprogramming adult cells into stem cells would assure their compatibility with consumers, preventing rejection, and due to the nature of stem cells, one would have an unlimited source of cells to use. Once these cells have been generated, scientists could manipulate individual neurons to form connections with the sensory electronic devices. Current research is exploring ways to manipulate individual neurons, controlling their movement and connections. Here is a video where scientists have used chemoattractants to force neurons to grow into specific compartments and towards specific directions. Furthermore, scientists have been able to create connections between neurons and other cell types using things like microfluidic chips, which are small devices that allow microscopic levels of fluid to flow through them in a controlled manner. They have also been able to form neuronal and muscular connections mimicking natural forming neuromuscular junctions, which is how your brain signals your muscles to fire. One could imagine in the near future the ability for scientists to connect neurons directly to sensory devices that could read signals from the nervous system and then have that device communicate with other cyberware throughout the body using wireless communication methods. You might still be wondering how scientists could even interpret signals from your brain and thoughts, whether they were brain waves or direct electrical signals, and convert these into the proper desired function. One possibility is through the use of artificial intelligence, such as neural networks. An artificial neural network is a collection of interconnected nodes, where the nodes and edges in the network are a representation of a neuron within a brain. Neural networks have famously been used for image analysis and classification, such as Google's DeepMind, which has been able to learn and classify images of cats versus other things such as humans, using the many images Google has access to. DeepMind has even learned to train a computer to beat humans in chess and even StarCraft. Neural networks work by inputting lots of training data into one side of the network and allowing the network to learn how to differentiate between two or more classifications, such as images of cats, dogs, Militech agents, or even the Voodoo Boys. Underlying this learning are a set of scoring algorithms, optimization functions, and other hyperparameters that I can go into in a different video if you all are interested. The curious thing about neural networks is that they are hard to interpret, so even though they can very accurately classify something, it's hard to know how they are doing it. As one could imagine, though, given enough data of brainwave recordings or electrical signals from the brain, scientists could use neural networks to classify the desires of an individual and translate these desires into function, such as moving your robotic arm, scanning people on the dangerous streets of Night City, or brandishing your mantis blades during an altercation. To make these commands even more accurate, one could also input muscular system signals, both electronic and mechanical, and even speech commands. Imagine simply whispering scan or mantis just loud enough that an audio detection device implanted near your vocal cord or mouth could pick it up, allowing you to have even better control of your cyberware. Regardless of the input, there are more and more machine learning algorithms that are being utilized for all sorts of automated tasks, and this seems the easiest way to gain control of implanted cyberware. Although we are quite far from being able to visit our local Ripperdocs to obtain the latest cyberware modifications, one can already see the foundations of the science and technology that will one day lead to these enhancements. We've learned that it will not only take a deep understanding of engineering and the integration of electronic devices with our biology, but it will also most likely require an extensive knowledge in manipulating stem cells and genetics. The recent advancements made in the field of machine learning and artificial intelligence has shown a great deal of promise in the interpretation and automation of complex signals, such as the ones which would link our biology to robotic devices. One day, these advancements, along with novel discoveries in stem cell biology, robotics, and computing, will allow for us to finally fully integrate our bodies with machines. So, would you want to modify your body with cyberware if you had the opportunity? This video hasn't touched any of the moral and other philosophical aspects of cyberware enhancements. Do you think it should be embraced, or heavily regulated and or even outlawed? If you're interested in these topics, let me know, and I will do another video on transhumanism and the moral aspects of cybernetic modification. Also, if you're interested in additional videos where I take an even deeper dive into the science behind specific modifications in cyberware, such as the arms or the central nervous system, please like, subscribe, and comment below. In addition to more videos covering Cyberpunk, please let me know if you are interested in seeing the science behind other games or even movies, and I will try my best to cover these as well. Thanks for watching, and I'll see you all at the Singularity.